we continue talking about solving systems of equations, we're going to solve, this curriculum talks about solving one variable equations with systems. And you may have been presented, it's very similar to what we would have called the substitution method. So when you're looking at this, think that's really sort of what we're doing is we're substituting in our variables, substituting in for y and equations, stuff like that. But again, the substitution method is something that you may have experienced before. And so we want to be able to solve a one variable linear or quadratic equation by graphing a related system of equations. So remember that if I take this example that I have, and I have y equals 2x minus 3 and y equals negative x plus 3, that's a system. And when I graph it, I'm going to graph it real quick. And in graphing them, I see that my system actually is, the solution lies at point, not 0, it lives 2 comma 1, right? My point 2, 1. And so that would be the solution of this system. But now if I were to look at it as a one variable, and what they're doing here is we're solving equations using a system. So if I were to bring that over here and say, well, you know, I'm going to do that substitution here, and we're going to end up with 2x minus 3 equals negative x plus 3. Right? So I made these two things equal to each other. If they're both equal to y, then of course they're both equal to each other. And I'm going to solve them as if I were solving a multi-step equation. So in doing so, I'm going to use my inverse operations to combine like terms. And I'm going to have 3x, right? Minus 3 is equal to 3. Go ahead and continue with my inverse operations. And that is going to 0 out, so I'm going to have 3x is equal to 6. Divide both sides by my coefficient, and it looks like I'm starting to get x is going to be equal to 2. So it looks like the solutions, when we're looking at these solutions, when we're talking about these one variable equations with solutions, the solutions are going to be my x value. Because sure enough, right here, when I solved for x, you know, x equals 2. And if you see the comparison here, x equals 2, well, x2 is the x value of my intersection point. So that's why here where I say my solutions are going to be my x values. They're going to be the x values of the intersection point. And then I have roots on here because we just want to remember that roots are the x values of the x-intercepts of a quadratic equation. And then, of course, a quadratic equation is an equation with the highest degree variable to the second power, reminiscent of something along the lines of y equals x squared is a quadratic equation, parent function. So, moving on with this, let's look at some examples. And that was just sort of tying those two things together. Back here, and we said, hey, the solutions of the system are always going to be my x values. This one, where you can see it, we're doing here, and remembering that the solution to a system is going to be the x values in this case. So solving one variable equations with Swiss systems, it's going to be the x value of our intercept point. Solving a linear equation using the system. Okay, so I'm going to use it using a system. So when I rewrite these, this can be rewritten as a system. 3x plus 5 and, y equals 2x minus 7. So when I go to graph those, I can graph them on my coordinate plane. Goodness. And I'm going to go ahead and graph those real quick. Okay, so what I've done here is I've gone ahead and drawn my coordinate plane, my x and y's. As you can see, I've labeled my axes. I've also gone 2, 4, 6, 8, 10. What I've done is I've made my increments be the value of 2, just because I need to use some larger numbers when it comes to graphing. And I have graphed this first equation in green, this first line, and I started off at 5, my y-intercept, and then I did the slope of 3. So it is 3 over 1, so I went down 3 over 1. So I have my slope there, and I've drawn in my line, and as I go to do this second equation, I will start off at negative 2, 3, 4, 5, 6, 7. Negative 7 is my y-intercept, and I'm going to go up the slope of 2. 1, 2 over 1, 1, 2 over 1. Goodness gracious, huh? Now if you look, gosh, that thing is going to connect somewhere down here, and it's going to be off my graph. So I'm not going to continue to graph that, but what do I do know about that? You know, what are going to be the solutions of the system? All right, so the solution of the system is going to be the x value. So I could have graphed it, and we would have had an intersection point way down here somewhere, and it would have been that. What do we know about my solution? Hopefully you know that the value of x is going to be a negative number because of the quadrant that we're in, right? Quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. So in quadrant number 3, my x values are going to be negative. And we can test that by solving this. If we were to 3x plus 5 is equal to 2x minus 7. And if you solve this using your inverse operations, and sure enough, look at that, it turns out that x is going to be the value of negative 12. And sure enough, that is going to be a negative number way down here somewhere. So just keep that in mind. The solutions to my linear equations of a system are going to be the x values, not necessarily the y values. Aren't as easy as this one, you know, just understanding systems to solve equations as well. So as we now look at this next example where we're using a linear and a quadratic using a system, and we're going to include a linear and a quadratic equation. This is linear because it is x to the first power, and this is quadratic because it is x to the second power. So if I create that system, I'm going to have y equals negative 2x plus 3, and y is going to equal x squared minus 6x plus 3. And if I go ahead and put that on an ordered coordinate plane, now the easiest portion of this system for me to graph is going to be this linear equation right here. And I'm going to graph that starting off with my y-intercept and then just going to work my slope, which is negative 2, to graph that line. So in doing so, if I start off at 3, there we go, and I'm going to go down, down 2 over 1, down 2 over 1, down 2 over 1, and let's see if I go ahead and I go up 2, back 1. Now I can go ahead and connect my linear equation as I graphed it, and again that is y is going to be equal to negative 2x plus 3. And when I go to graph my quadratic equation, there's multiple ways to graph this, but what I'm going to do is I'm going to go ahead and I'm going to plug in values. I'm going to plug in values possibly from when x is negative 1 to, I don't know, 1, 2, 3, 4, 5. X is 5. So that's going to be a decent sized table. So when I create this table, using a table, what I'm doing is I'm going to input values of x into my equation, and that is going to give me my output values of y, which in turn, if I have an x and a y, then I can create the ordered pair to go ahead and graph it. So I'm able to graph without a calculator. So give me 1 second. And what I've done here is I've created a table, and I'm going to plug in these values of x into my equation to get out values of y, so I can go ahead and graph them. So when I plug in negative 1 into my equation, I replace x with negative 1. So here I end up with negative 1 squared, which is going to be 1, 1 plus 6 plus 3 is going to be 10, I believe. So I am going to have -1 and -1 and 10 will be my ordered pair, which is going to be off my charts up here somewhere, so I'm not going to worry about that. Now when I go to this next one, I input 0, I'm going to have x is 0 and y is going to be 3, right? Because 0 minus 0 plus 3 is going to be 3. So when I graph that, 0, 3, and let's see if next one is going to be 4 minus 12 plus 3 is going to be 5. So I'm going to have 2 negative 5, right? Because that is a negative 12. So I'm going to have 2 comma negative 5 is another ordered pair. 1, 2, 1. Going to go over 2. Going to go 1, 2, 3, 4, 5 is going to be that point. And then 4 is going to be, you're going to have 4 squared minus 6 times 4 plus 3. So that is going to be 16 minus 24, which is going to be 8, negative 8, negative 8, negative 8. I'm sorry, negative 8 plus 3 is going to be a negative 5. So I'm going to have 4, negative 5. So that's going to be 1, 2, 3, 4, and negative 5. So it looks like we may have found our intersection points here if I were to graph it. But just to throw 6 in here just to make sure, 6 squared minus 6 times 6 plus 3 is going to be 36 minus 36 plus 3 is going to be 3. So I'm going to have 6 comma 3, which is going to put me in 1, 2, 3, 4, 5, 6, 1, 2, 3, right there. And so my equation, when I graph it, is going to look something like this. Right like that. And it looks like I do have some intersection points, which are going to fall right here, which is going to be 0, 3, and right here, which is going to be 1, 2, 3, 4, negative 5. And so remember that my solutions to this are going to be the x values, so it's going to be x is equal to 0 and x is going to be equal to 4. So I'm able to solve that by graphing to see where those two functions overlap. And that's using a linear and a quadratic equation. And let's see if I were to show a picture of that. You are able to plug that into the calculator, and that's what it would look like depending on your graphic image. And you can see my overlaid equations. And then, of course, that they do intersect at the same points that we have calculated. So, we were using a little bit of a challenge sometimes. So as we talk about a quadratic system, and we want to know what are these solutions. So if we rewrite this as a system, we have y equals going to the next one where we talk about two quadratic equations. Okay, so now when we go to use a two quadratics, what we can do is we can graph them using the table that we had used before. But what the easiest possible way here is going to be to use a graphing calculator. So when using that graphing calculator, what we can do is, let me get this junk out of the way, right? What you want to do is you want to turn around and we are going to put this system, so I have y equals 2x squared minus 8x plus 7, and y equals negative x squared plus 4x minus 2. And hopefully you remember that just some of the characteristics, that since this is negative, it opens downward, and since this is positive, it opens upward. So in the end, we're going to have, it's going to do this somehow, and we're going to have some intersection points, hopefully. But one will open upward, one will open downward. And so in doing it, we'll go ahead and we're going to use a graphing calculator, and we're going to, in y1, I'm going to put one equation, and in y2, I'm going to put the other equation. So I'll have 2x minus 8x plus 7 in y1, and then I will have negative x squared plus 4x minus 2 in the y2, and I'm going to hit graph. So as you can see here, what I've done is I've gone ahead and I have inputted into the graphing calculator. So you hit y1 or y equals, and then you can type in one equation, then arrow down, you can type in the next equation. And then what we're going to do is we're going to hit the graph button so it appears on our screen. And looking at this, we can see that it appears that we do have an intersection here and a section here, but it may be too close for us to see. But what we can do is we can just go ahead and zoom out, and so we hit zoom, and then we arrow down to out and hit enter twice, and in doing so we should get a new picture that looks like this. And you can go ahead and disregard what I just said. What we want to do is zoom in and zoom in, so you hit the zoom button and then you arrow down to zoom in and hit enter twice. And now in maybe changing my window a little bit and looking at this, we can see that I have enlarged the picture, and my my two intersection points have gone from there to here, and then we should be able to see, let's see here. So my x value is going to be x is 1, and then y is 1. So this point right here is going to be 1, 1, and then this point right here is going to be, put it down here so we can see it. Looks like 1, 2, 3. So x is 3, y is 1. So those are my two intersection points. So my solutions, remember, are when the x values. So it's going to be x is equal to 1 and x is equal to 3. And that's where those are those possible solutions for this equation. Now, looking at, we were using solutions. When we have a linear and quadratic equation, we're going to have three possible solution types. Two solutions. Right here is what we had on our previous example, where we have a parabola and then a line cuts through that parabola and touches it in two different places. Then we have a parabola, and then where a line comes and touches it just at one spot as a tangent. So that would be one solution. And when we have a parabola and a line that do not intersect, that is no solutions. So those are your possible number of solutions. And then when we have a quadratic and a quadratic, well, we actually have some solutions here that they don't talk about. And I'll show you that. But we do have here where we have two quadratic equations that intersect at 2 points. We have two quadratic equations that intersect at just 1 point. And then we have two quadratic equations that intersect at no points, so that's no solutions. One thing that we don't talk about is, how about that quadratic equation? That is the same quadratic equation, and it turns out that that is going to be infinite solutions when it turns out that we have the same quadratic equation, the system. So there you go. Those are the types of equations we have.